Gary, I'm going to turn the floor over to you.
All right, very good. Hi, guys, and welcome. Thanks for taking the time today. Just a quick introduction for those of you that are not familiar. Cleerline Technology Group was actually formed in 2012, so we've been around a while. And for any of you out there who may be a musician, you're possibly familiar with the name D'Addario. D'Addario is actually our parent company. And they are the largest manufacturer of musical instrument accessories in the world. They're based on Long Island in New York, and they're actually several generations old. So they actually have a lineage of almost 400 years. And so they're our parent company. But Cleerline Technology Group is also made up of two other subsidiaries as well. The first one being Planet Waves. If any of you have ever used Planet Waves Quick Connects for coaxial cable. The other one being Custom Install Supply. Custom Install is basically an online house that supplies pieces and parts to the likes of Magnolia and others as well. And it was originally formed by two high-end residential custom integrators. So we've got a good combination of ownership here. We've got the sensitivity towards custom install and the ability to apply experience to what you go through on a daily basis out there on site. We've got the solid foundation, both financially and from an engineering perspective, that D'Addario brings. And we've also got some experience from, again, a custom install perspective from the Planet Waves aspect of things. So Cleerline Technology Group was formed from those three experiences in the industry. And essentially what we wanted to do was evolve the fast connect type technology that came with Planet Waves into a technology that we knew would outlive copper. Basically, we're at the point now where copper is beginning to approach the end of its lifetime. Although I don't think it'll ever go away, it is being tested right now to its limits, and we'll talk more about that in a second. So anyhow, Cleerline was really come about from the same concept of Planet Waves, where you can very easily and simply terminate fiber as you could the original Planet Waves copper solutions. So with that, I'd like to encourage you to start thinking a little bit about, why we're even talking about fiber. The first that comes to mind and is the obvious one is data throughput, bandwidth or speed and distance. Fiber optic cable's been around a long time. It can actually transmit more data than any other medium we know of. And we'll talk more about this terminology in a second, but a multi-mode cable can send 100 gigabit per second signals over 300 feet without any problem at all. And if you start talking about single mode cables, you start talking about petabits, and that's 1 times 100 to the power 10 with 15 zeros after it. So that's a pretty big number, and that's the amount of data that can pass through a single mode piece of fiber optic cable. So throughput, bandwidth is not a problem. Speed, obviously we're dealing with a medium that is based upon light. So we're almost dealing with the speed of light through a piece of glass optic cable. And then distance. So we can transmit and receive that data over much greater distances than we can with any other type of infrastructure. Some of the peripheral benefits that come with using fiber when you're considering using it, it's non-conductive. So it's completely immune to things like power surges, ground loops, electromagnetic and RFI interference. So if you're doing a lot of work outside, or if you're in an environment where there's lots of thunder and lightning, for instance, or power surges of sorts, the use of fiber helps to overcome a lot of the challenges that otherwise a copper infrastructure might bring you. It doesn't corrode. There's no corrosive parts and pieces in it, unlike copper, which does corrode. Fiber optic is made up of plastics and Kevlar and ultimately glass, so it doesn't corrode. And again, if you're in an environment that's humid or outdoor environment, obviously corrosion needs to be a consideration during your installation. So it's also very easy to terminate. A lot of people have the misconception that fiber is difficult to terminate, and I'm going to prove to you in a little bit here that that's not the case. With the technology that we have introduced to fiber, it becomes very easy, very quick, and also very safe to use fiber optic. Hence our little trademark slogan there, that the SSF part stands for stronger, safer, and faster. So anything that you may think is tricky with fiber or is needing training, we can kind of overcome that with the use of our technology, which I'll show you in a second. Fiber is becoming more affordable. The disparity between the endpoints that you use with fiber versus copper is becoming much smaller. It used to be so that copper infrastructure was a great deal cheaper in itself, and the endpoints were significantly cheaper. But now you walk around the show floors at places like CEDIA or Infocom, you'll see a lot more fiber-based systems, and because of that, the solutions are coming down significantly in cost. So the disparity between fiber infrastructure and its components versus copper is becoming far less. And it's lightweight. So being that it's made of glass and plastic, it's not copper based. It's very lightweight. It's easily kept on the truck, and you can carry it easily. You can pull it easily, simply because it's far lighter in weight than traditional Cat 6s. All right, so moving on. Why fiber for AV? Well, I'm sure some of you are familiar with the fact that we're at the point now where HDMI 2.0, which is the standard HDMI spec for today's video, requires 18 gigabit per second throughput. Unfortunately, 18 gigabit per second cannot pass through a piece of Cat 6. So we're dealing with things like compression, where you have to take a certain element of that signal, compress it down to under 10 gig in order to pass it through a piece of copper. Now, there's a lot of compression algorithms out there which are quite good, and I know you guys, a lot of you carry the AV Pro Edge solution, and their compression algorithm is particularly good. But at the end of the day, they are sacrificing some of that original HDMI 2.0 format and compromising a little bit to be able to get it down to a 10 gig level to feed it through a copper infrastructure. So it's relevant for us because really we've already exceeded the 10 gigabit per second limitation of copper, and not only that, we're heading towards HDMI 2.1, where it's going to be 48 gigabit per second, and obviously the compression at that point becomes far more significant. You're going to be giving up a lot more with HDMI 2.1 in order to feed that down copper infrastructure. So things like 8K, enhanced HD audio, eARC. If we get into virtual reality and high dynamic range, so all of these different things with the deep color bit depth and the greater color spectrum that comes with HDMI 2.1 is all going to be needing to go over fiber optic infrastructure instead of copper. And again, one of the challenges we face within AV is glitches and snow effect and dropouts and pixelation due to various external sources like EMI and RFI. Once again, as I mentioned earlier, fiber optics completely immune to those things. So again, it can help improve your installation by running fiber in place, or as well as copper. So this chart is something that I find interesting and is actually very relevant for you as installers to be able to have a conversation with your end users. Obviously, when end users go out and they see it at Costco or Best Buy or wherever, they see a new display screen and it's got 4K on it. There's much more to 4K than that. Okay, there's basic 4K, 4K 30 hertz, and that goes back to the HDMI version 1.4, where you might only be dealing with very high color compression ratios, not such deep color bit depths, no HDR, no wide color gamut, things like that. And we're dealing with bandwidths at that point, and the formats of HDMI that can easily be fed through an infrastructure that only up to 10 gigabit per second. But once we cross that 10 gig and we start encroaching upon 11, 12, 13, up to 18 gigabit per second, that's when we're starting to introduce HDR. We get that deeper color. We don't want any compression. We're dealing with higher frame rate, refresh rates, and we're going from HDMI 1.0 to 2.0. That's when we're really getting into the need to consider fiber infrastructure, or you're going to go back to the compressed copper infrastructure type system, which again presents its challenges and also brings some compromise with it. So this chart may be familiar to you. It's actually written for us by AV Pro Edge. So they actually publish this in their literature as well. It is being updated also to include HDMI 2.1, where we'll see 8K and 120 frame per second refresh rates and higher bit depth, etc., etc. So this is even though this addresses HDMI 2.0, this is almost out of date as it stands today. But it's a very good story to be able to tell your clients why it is we're talking about fiber versus copper. Okay, so getting on to the fiber itself, I'm going to assume that some of you are familiar with fiber, but many of you are not. Fundamentally, there are really three components to a fiber optic cable. There is the core, and now that's the very center of the cable, which is made of a pure glass. And that is a very tiny glass core, which is about the same size as a human hair. Around that, you've got another layer of glass as well, which it behaves much like a mirror, and that just has a different refractive property to the core and causes the light to bounce down the core instead of out to space. So it's kind of like a mirror that keeps the light within the core. Around that, you've got different coatings called the buffer jacket. You've got basically a primary buffer and then a secondary buffer. That first coating is 250 microns, which is 1/4 of a millimeter in diameter. So again, very, very small. You can understand here that we're dealing with something that's quite literally the size of a hair. And then above that, you've got these things called strengthening fibers or Kevlar strength members. They're in there really to protect the fiber underneath it, and that's what you would use to pull the fiber. And then from that, you've got cable jacketing, and you may have an armored jacket around that for direct burial, things like that. But fundamentally, fiber optic cable is consistent of a core surrounded by a cladding, both of which are glass, and then you've got these various coatings around that to protect the glass underneath it. Now, when you prepare the fiber for termination, the challenge is that each of those layers, the coatings and the cladding, has to be peeled back to or stripped back to a certain length. And then once you get to the cladding, you've got to clean it with alcohol, and obviously being the size that it is, very tiny, it can be very, very fragile, easily broken, and also quite dangerous. When you're at that cladding layer, it quite literally looks like a human hair. If you poke yourself with it, it could potentially puncture soft skin tissues, and if you break the end off into your skin, it can be very uncomfortable and actually quite dangerous. So there's very specific procedures that you need to go through when terminating and handling and installing conventional, traditional fiber. But fundamentally, what you're looking at is a core, cladding, and coating, and that's essentially what a fiber optic cable is made up of. So this slide here explains to you the difference between two terminologies which you may or may not be familiar with. Single mode fiber is not to be confused with single strand. Single mode literally means there's a very tiny 9-micron core down which only one beam of light is shone. So you've got a 9-micron core with 125 micron cladding around it. That's the mirror piece that I was explaining to you just now in the previous slide. So a single mode fiber is just a single strand of glass or single strand of fiber with one beam of light that goes down it. All right. And single mode is generally used for longer distances and higher bandwidth, and we'll cover a bit more about that in a second. So not to be confused with single strand, single mode. Now the multimode, as you can see on the bottom of the slide there, has a bigger core of 50 microns, still has that 125 micron mirror or cladding around it. But because it's a 50 micron core, we can fit many, many different modes or beams of light down it at one time. That gives us the ability to do slightly more with it. But in actual fact, it does reduce the amount of bandwidth and distance that multimode is capable of carrying. So that's the difference between multimode and single mode. And the numbers that I'd like you to go away from with this slide are the 9-125 and the 50-125. Whenever you see that on a spec or if you see that on a cable, those numbers will immediately tell you that you're dealing with single mode fiber being the 9 or the multimode fiber being the 50. Okay, and for your information, a micron is 1/1,000,000th of a meter. So again, we're talking about a very, very small medium here. Okay, so how does it work? I mean, basically, single mode and multimode are not compatible with one another. A lot of people say to me, can we use single mode endpoints on multimode cable? You cannot know, because they actually work on different frequencies. Now, you and I as human beings, we can see the visible spectrum of light, which is anywhere from 450 to about 760 microns, nanometers. And that's the visible spectrum that you and I can see. And then we've got things like microwaves and infrared and UV and radio waves and things that are all within the different frequencies of spectrum. Multimode sits right there just outside the visible light spectrum. So multimode happens to work at 850 to 1300 nanometers, and single mode works at a different frequency of 1310 to 1550. So that's why they're not compatible. They are working at a slightly different frequency of light. Okay. So again, here, just for reference, a nanometer, which is the wavelength we're talking about, is a billionth of a meter. So we're talking about some really small numbers here when it comes to fiber optic. All right, so I mentioned earlier that single mode and multi-mode are used for really two different applications. The reason being is that single mode, as I mentioned, just has that one beam of light down it. And so that can carry a high bandwidth over a long distance. The reason multi-mode is used for shorter distances is because we have multiple beams of light at different angles shining down the core, and you can see we've got these what they call high order or low order modes of light, some of which go quicker than the others, although you and I can't tell the difference because it all happens at a split second. But these beams of light all travel at a different speed through the multi-mode cable, and that results in what they call modal dispersion. In other words, they kind of get out of phase with one another after a period of time. And so that's why the multi-mode fiber is generally used for shorter distances versus single mode being used for longer distances. So I don't want to get too deep into that. I just want to explain that single mode and multi-mode are different, not to be confused with single strand and multi-strand. Okay, talking a little bit about multi-mode. Again, the lower bandwidth and shorter distances. And we do actually have 3 or 4 grades of multi-mode. Now, this can get a bit confusing, but I don't really want you to focus on anything other than really the OM3. OM3 is probably the most used fiber in our industry. As you get more into medical and more critical type environments, maybe you would use an OM4. OM1 and OM2 is becoming somewhat obsolete, OM1 specifically. OM1 we're not going to really talk about because we actually don't offer that, and it's becoming quite an obsolete product. OM2 is generally the grade of fiber that you would find in active optical cables and things like that, which we'll talk about again in a little while. But just to give you an idea, you can see here that OM3 multi-mode cable, we can carry a 10 gig signal, so 10 gigabits per second. We can carry that up to 1,000 feet, give or take. It's not exact. It's not an exact science, but it depends on the endpoints you're using. But a general rule of thumb is that 10 gigabit per second can be carried over OM3 up to about 1,000 feet. If you'd like to extend that and you need to get a bit further, not too much, you can either go up to an OM4 grade fiber, or you can start talking about the single mode, as I mentioned earlier. Okay, so you can see on the chart here, we can either start talking about 40 gig or 100 gig, where we can get up to 100 or so meters or 330 feet or so using that same OM3 cable. So the bandwidth and distances are far greater than any copper-based infrastructure that we know of. Single mode, very quickly, again, higher bandwidth, longer distances. 10 gigabit per second, for instance, we can go literally dozens of kilometers. We can take 10 gig, up to 40, 45 kilometers. And again, these are just really broad specs. It depends entirely on the hardware you're plugging into it. Some can do more, some can do less. But to give you a rough idea, these are the type of distances we're talking about. So if you have a property on a farm or something like that, or an estate where you might have a security gate or a pool house or something that's the other side of the property, if you get beyond that 1,000-foot type mark, you're probably going to be starting to talk about single mode fiber and the hardware to go with it. Okay, so I've tried to explain a little bit about the basic construction of fiber and the differences between the two primary types of fiber, the single mode and multi-mode. You'll also notice that when you start using the fiber, there'll be different colors. So generally speaking, those colors kind of tell you what you're using. OM1 and 2, like I said, is kind of obsolete. That's an LED-based fiber optic light, which is an orange in color. The one we're going to be specifically using most of the time is the OM3, which is the aqua color, and that's more of a laser-based source. And as you can see, the distance and the bandwidth gets higher and higher as we go from the OM1 to 3 to 4, and then ultimately to the single mode, which is the yellow on the end there, which is a laser or laser diode source where you can carry almost an infinite amount of bandwidth over an infinite distance. Okay, so I just wanted to show you that slide because those colors are industry standard. So if you see those colors, you know what you're kind of dealing with. All right, people often ask me why, can we use bulk fiber to make Toslink cables or optical audio cables? The answer is no. And the reason being is, again, without talking too much about the numbers because it's boring, fiber optic works in a different frequency range or light spectrum than what a Toslink cable does. Toslink cables work just within our visible field of spectrum of light. So as you know, you can see the beam of light coming out of a Toslink cable. That's not the case with fiber optic infrastructure. So we cannot use standard bulk fiber to make Toslink cables. They work at a different frequency over a different technology. Single mode, generally speaking, like I said, is yellow. We sell that for greater distances. Normally, you would be phoning us or calling us because a dealer installer might need to be using that for 2, 3, 4, 5,000 feet. So we can cut that from a bulk spool and we can ship that on greater lengths than is necessary for multimode. Generally speaking, single mode is used between buildings. So the greater distances between buildings. To note here, the single mode is actually a cheaper cable than the multimode. But interestingly, the single mode devices that you plug on the end are far more expensive than the multimode devices. So imagine you're running, the ISPs, the service providers are running fiber infrastructure down the street. They're using a very inexpensive single mode infrastructure for that. Hundreds and hundreds of strands of it, but it's a single mode type application where the fiber is actually quite cheap. And the hardware on the end of it is more expensive. Versus, on the other hand, the multi-mode cable being a bit more expensive, but the optical endpoints are far less in cost. So that's generally what we see used in our industry, primarily because we're not dealing with lengths of several kilometers or miles at a time. We're generally using this for what they call the horizontal topology, which is the within the building, so to speak, where we don't need to get those distances. Okay, so having talked a little bit about conventional or traditional fiber, this slide explains how Cleerline is different. And like I mentioned, the SSF is stronger, safer, and faster. And what that means is we actually surround our cladding, and I'm hoping you can see my mouse here. We actually surround our cladding with a proprietary polymer. So you'll see we've still got the glass core, much like a conventional fiber. Now realize that the 9 micron or the 50 micron for the single mode and multi-mode, that still applies to us. That's a very critical number. That size is an industry standard. And then we've got the cladding around that. So we still have that mirror, if you will, the same as a conventional fiber, the cladding. And again, it's important to know that the 125 here is a standard number. So although we actually add the polymer around the glass, the polymer is what takes us out to the 125 micron, all right? So whereas you've got, the dimensions here and here on a traditional fiber of let's say 50, 125 for multimode, it still applies to ours, although we've got that polymer. And that's very important to know because what that means is our fiber is compatible with anybody else's connectors and our connectors are compatible with anybody else's fiber. Okay, so it's fully compatible with other industry standard product. It's not a proprietary system, if you will. And that's very important to know. Now, the relevance of that polymer gives it a few things. It gives it a lot of strength. This makes it a great deal stronger than any other fiber out there on the market. And I can give you the tests and the specifications behind that if you need them. But that polymer gives us a great deal of strength. It gives us a pulling a pulling strength of over 100 kilos or 200 pounds. Okay, whereas a regular fiber optic or even a copper cable, if you pull on that harder than 25 or 30 pounds of tensile stress, you're going to start to compromise those cables. Okay, so that polymer there makes it very, very strong. Also makes it safe and protects the glass all the way to the tip. You remember on slide 1 or 2, I explained that you have to be very careful to prepare these fibers and these different layers back down to a very specific length before terminating. None of that applies to Cleerline fiber because the polymer protects our cladding all the way to the very tip. It's a very important piece to know, simply because any moisture or humidity or dirt that would otherwise get onto that cladding can cause the fiber to fail and break down and not work over a very short period of time. That doesn't happen to us because of that polymer. So you'll see here that the biggest difference in this diagram is that we only go up to the next layer, the 250 micron layer above that, which is generally a hard acrylate which you have to use strippers to remove. Ours is actually a soft acrylate, so you don't use strippers for us. So not only are we making it stronger and safer to eat and easier to use, we're reducing the amount of tooling and time that it takes to prepare for it. All right, so you actually use finger and thumb to remove our soft peel acrylate versus a hard acrylate needing to be removed by fiber strippers. Once again, if you don't practice the termination of fiber on a fairly frequent basis, using fiber strippers is actually quite complicated, and you can easily break the fiber underneath it. With ours, because the polymer always protects the glass, stripping and preparing our fiber is actually very simple, very safe, and very quick. So that's fundamentally the difference between us and a traditional fiber. All right, so I've spoken a little bit about this already. Our fiber can actually, be bent and has a bend tolerance of over 10,000 times that of a competitive fiber. That polymer really gives us a lot of strength. It's got a bend radius of down to 2.2 millimeters. You can literally tie our fiber into a knot. Whereas with other fiber, bend insensitive fiber or Cat6 or Cat5, you've got that maximum bend radius where if you bend beyond that, it starts to compromise the twisted pairs and obviously doesn't work as well. All right. Same with the installation pull force. Ours has got a tensile strength of over 200 pounds. You can really tug on it versus a Cat6 being 25 or 30 pounds before it begins to get compromised. Much safer and easier to work with. You can literally terminate within a minute, okay? So you can save yourself a lot of time terminating these if you've got lots of them. And as I mentioned earlier, they're backwards compatible with all other industry standard connectors. All right, let's talk a little bit about the different cable constructions, because this is sometimes a bit of an uncertainty to people. Once again, so simplex, one strand of fiber, not to be confused with single mode. A simplex cable or one strand of fiber can either be single mode or multimode. That might be used in an application where the device that you're plugging into it just requires one strand of fiber. If any of you have used the AV Pro fiber extenders, HDMI over fiber extenders, they only use one strand of fiber. A very clever device in there called a transceiver actually sends information backwards and forwards down the same piece of fiber. Duplex, for any of you that have ever used an SFP, a small format pluggable device that goes into the back of a network switch, they use a two fiber infrastructure, a duplex, one for transmit, one for receive. Again, we're going to be talking a little bit more about the hardware at the end here, and I know Rick wants to mention a few things about that. But so simplex and duplex really is determined by what application you're using it for and what the hardware requires. Micro distribution, this is basically where you've got several of those small strands in the same jacket, and those would be used to perhaps interconnect two different racks, or from a demarcation point to a rack and things like that. It gives you a very high concentration of fiber all within one very, very small jacket. A more traditional approach to that, the same thing, is to have what they call a breakout. So this is basically several strands of fiber. Each one has its own 2 or 3 millimeter jacket around it for extra strength. If any of you have ever used the Crestron fiber cable, this is what you would have been using, is this type of construction, a breakout cable with individual jackets around each of the fibers. We also offer Rugged microdistribution, again, it's basically the same as the microdistribution you see here with several strands in the same tube, but it's got a ruggedized jacket around it. Okay, so that could be used if you've got outdoor environments where you can run through a conduit. It is the jacket around it here, the black part is, you know, ruggedized, it's tough, it's UV resistant, it's rodent resistant. It just doesn't have the armor around it that you would otherwise use for a direct burial, as in some of the others we have. So you can see on the next one down here, the corrugated ACS, that's got a toughened steel surround as well. So you can actually bury that directly in the ground. Again, fundamentally, when you strip all that jacketing off, you've still got that same fiber underneath that is still terminated in the same way as normal. It's just got that tough jacket around it. Okay. Then we've got this aluminum interlocking armored, again, more of a commercial type space for warehouses and such, where it comes pre-threaded in this aluminum interlocking conduit. Tactical cable, if anybody out there is doing temporary road shows or live rental and staging events, the tactical jacket on this is very much like a microphone jacket. It's got no memory to it. So you can use it for temporary installations and easily and quickly terminate if the cable was to become compromised during a live performance or something like that. Fiber plus power. Obviously, we've got to deal with PoE sometimes. So we've now got the ability to carry data for video, but then we've got the PoE requirements or the, you know, if you've got CCTVs or something that require a low voltage power supply as well, we've got 2 strands of copper in here and the multi-strand fiber in there as well. So we can do almost like the duplex, right, where we've got 2 strands of fiber. We can now do multiple strands of fiber in one jacket and 2 conductors for power in another socket, in another jacket. And then we can do some custom bundles as well. So we've got like 2 Cat6s and 2 fibers in here. We can do other constructions as well. So if you want to do a custom bundled infrastructure for your structured cable infrastructure, you can obviously run either of those separately, or you can run them into a single jacket. Okay, this is something else that often, you know, gets confused by people is, oh, what type of connectors are there? Realistically, the only 2 connectors that you're going to be concerning yourself with are the 2 on the left, the LC and the SC. And again, which connectors you use is dictated by the hardware you're plugging into. I know that, you know, for any of you that might have used the INEOS fiber extender, the HDMI over fiber extender, they use this square SC connector. Okay. Any of you that have used, you know, perhaps the SFPs on the back of network switches or the AV Pro fiber extenders, they use the LC extenders, but the LC connectors. So again, that the use of whichever connector is determined by the hardware you're plugging into it. You don't really get to decide that. All you need to decide is, am I using single mode cable or am I using multi-mode cable, depending on distances which I'm running the cable. All right. And so a single mode connector would be blue, a multi-mode cable would be aqua in color. So you can differentiate between the 2. The only other connector you may see here is the ST connector. It's kind of like the fiber equivalent to the old BNC connector. This is used more within CATV or Pro AV, you know, rental and staging type applications as well as military. It's impossible to pull it out with actually rotating it. So it's actually quite a robust connector, but we don't often see it in the AV industry other than in Pro AV. And then the green one on the front here, if anybody is ever pulling fiber from the demarcation point where Verizon or some other ISP is bringing fiber to the premises, you'll probably see that they come into the premises with a green connector. That green connector just dictates the type of connection between it and the hardware that you're plugging into it. I don't really want to get too much into that as well, but if you run across this green connector because you're connecting to an ISP's fiber coming into the home or the property, you know, let us know and we can help you to be compatible with that. All right, just real quick, and I know Rick wants to kind of talk a little bit about more about this, but accessories as well. So we've got various accessories. We've got fan out kits to be able to build the cable up from that very small size up to the 2 or 3 millimeter jacket you can terminate onto. We've got breakout kits that can be used to help with cable management in the back of your racks. We've got SC to SC patch cables or LC to LC patch cables, again, both in single mode or multi-mode in various lengths up to pretty much whatever length you want. So as easy as it is for us to terminate our fiber, you can make your own patch cables, but if you don't want to, we can offer these patch cables from device to device. using the same fiber with the same strength, just pre-terminated at the factory. So finally here, I just want to talk a little bit about the other solutions we offer. So we've got obviously bulk cable. We've been talking about that, the connectivity, some of the patch cables. We also do a lot of enclosures. So when you start getting into fiber infrastructure, we can start offering you enclosures, rack mount assemblies, etc., etc. Naturally, the accessories. And again, much like you can use anybody's connectors with our fiber and anybody's fiber with our connectors, you can actually use anybody's tooling as well. You don't have to use Cleerline tooling. So if you already have, perhaps a Corning termination kit or a Belden termination kit, you can use that just fine. We offer these accessories for you, but you can use other people's as well. The same with the testing. We offer the testing equipment, so you can test the fiber once you've installed it, but you don't have to use our kit. It's not proprietary to us. Cleaning is a very important component to what we offer. Keeping the fiber tips clean and the connectors clean before you plug them in, keeping the fiber ports on the switches clean, realizing that we're dealing with something here that's literally the size of a hair. If you get a molecule of dirt or moisture or humidity on the tip, it needs to be cleaned. It's a very simple process. It just often goes overlooked. But that cleaning process can actually solve a lot of problems. So we sell the cleaning kits as well to go with it. And then we've got active optical cables. We've actually got the first 48 gigabit per second active optical cable that utilizes our fiber in it. Now, in complete transparency, you'll also see AV Pro Edge with a similar product. What they do is they actually use our glass. They use our bending sensitive fiber optic cable within their HDMI cables, so that it offers the strength that comes with our fiber, and more importantly, the ability to re-terminate it down the road if you need to. At one point in time, the HDMI head may become obsolete, perhaps not in our lifetime, but if it does, you can cut the HDMI head off and you can terminate the fiber inside. Because it's our fiber, you can terminate with conventional fiber connectors and plug it into tomorrow's or next generation fiber extender equipment. So it's truly a way of helping to future-proof your installs by using our active optical cables or AV Pro's active optical cables that utilize our glass in them. Okay, we've kind of gone over this a little bit already. We've got rack enclosures, wall enclosures, adapter plates, all the different things that you would require to build out the infrastructure behind the cable, as well as just the cable and connectors themselves. So again, with the limited time we've got today, I don't want to get too deep into that, but realize that when you receive the price list or take a look at our website, you'll be able to see all these different accessories to build out your system. Now, this is where I would normally go into the training and actually show you how to terminate. But for that, I'm actually going to bring up the website, and I'm just going to prove to you how easy and quick it is for us to be able to do the termination. So this video is actually about, well, I've cut the first minute off, so it's actually about 3.5 minutes long. And this just goes to show you exactly how quick and easy it is to terminate our cable.
Step 1. Unscrew the connector boot and slide onto the 2 or 3 millimeter cable jacket. If terminating 2 millimeter cable, slide the included yellow 2 millimeter build tube onto the 2 millimeter cable jacket. Using the 2 millimeter opening on the strippers, remove approximately 50 millimeters or 2 inches of the cable. Turn on the VFL verification light. Place the 2.5 to 1.25 millimeter adapter on the VFL. Remove the dust cap and place the connector onto the VFL. Ensure the activator slide tab is in the open position, being slid towards the rear of the connector. After that, open the hinge on the rear of the connector. Pulling the aramid yarns back, locate the SSF glass fiber. Using only fingertips or nails, gently remove the soft peel colored 250 micron coating completely from the fiber to within approximately 12 millimeters or a half inch of the cable jacket. Do not use the fiber optic strippers during this step. as they can damage the SSF fiber's polymer coating. To cleave the fiber for the SSF LC termination, hold the fiber at a slight angle downward and place the cable jacket at the 24mm mark on the cleaver. Ensure the fiber is straight in the groove and across the two pads being placed at a 90-degree angle to the cleaver wheel. Close the cover on the cleaver and firmly push the cleave wheel forward. Insert the fiber into the rear of the connector by placing in the V-groove at a slight angle and sliding forward until a small bow is created with the fiber and the light emitting from the connector verification window dims, being almost extinguished. Maintaining forward pressure on the fiber, slide the activator tab towards the connector tip to lock the fiber in place. Remove the connector from VFL. Install the dust cap. For 2mm cable, slide the previously installed 2mm yellow build tube forward and seat in the rear of the connector. Ensure the fiber is straight and place the aramid yarns to one side. Close the hinge. To complete the connection, slide the boot forward and thread one full turn to lock in the aramid yarns. Cut the yarns closely to the boot. Tighten the boot until secure. The connection is now complete. For more information, visit the technical resource page at clearlinefiber.com.
Okay. So as you can see, it's really quick, pretty simple. If you do it a couple of times, you practice it, you'll actually find that you can get it down to within a minute or so. Now, I know that Rick wants to talk a little bit and I'm running out of time, so I just want to cover this document real quick. I can send this to you, or it's available on our website. You can download it. When you're building up a fiber infrastructure system, this sheet kind of walks you through what you're going to need where. You know, firstly, how to choose your cable type, what's the hardware you're being plugged into it, how far are you running the fiber, and then choosing the connectors again is determined by the hardware you're plugging into it. So this kind of helps you walk through some of the decisions you need to make. Generally speaking, what we find people doing is you know, multi-mode on the shorter distances, and these are some on the back side of that same document. You've got some recommended infrastructure good practices. So if you're running from a equipment rack to a display, we would recommend a minimum of 2 strands, that duplex fiber that I showed you. You know, preferably though, we would like to see you run 4 strands, simply because we don't know what's going to happen in the future. You know, devices may need more terminations. One of the strands may be getting, you know, maybe gets compromised by somebody hanging a picture and putting a nail in the wall or something like that. So we would recommend on that type of application 2 to 4 strands, depending on your comfort or the budget of the project. So this document here really kind of walks you through some suggestions. If you've got any questions on what you might run to where and why, this document definitely helps. But if at the end of the day, if you need my help as well, I can also help you. My name's Gary. My email address is there, gary@cleartech.com. My cell phone number is there. I'm located in Pennsylvania, so I'm on Eastern Standard Time when I'm not traveling. So with that, I'd like to thank you all very much. I hope it was useful. We'll open the forum here to Rick to kind of go over the things he wants to talk about and to have any questions and answers.
All right, thanks, Gary. Yeah, I'm going to take over presenting for just a moment to talk about some of the hardware options that we have in our location and most of our other locations as well. And then I'm going to flip back to, oh, hold on. And then I'm going to flip back to you, and we're going to do Q&A.
Okay.
So, am I presenter now? It looks like I am.
Let's see. I think you are.
Yeah, and I am as of right now. Okay. So what I wanted to show is we talked about this particular product from AV Pro. So this is a fiber optic extender that it takes fiber natively right into the unit. And like Gary was saying, there's two basic ways that fiber can be used in our industry. They either they're devices that hang off of an SFP connection, or there are devices that take like the LC connectors straight into the device. And in this case, it takes the connector straight into the device. We would terminate it just like we saw and plug it straight into the device.
Hey Rick,
And these are
if you click on the EX0444 part number down there where it says product page, yeah, or that one, yeah.
yeah, I thought I had, oh, you know what? I do. It's right here.
Now
I
you
thought
can
I had a
go
picture
to
up of it.
resources or gallery. I think it's gallery.
Gallery, yeah.
Now
That's
you
what I
can
wanted
see
to
the
do.
side view. It
There
will
we
actually
go.
show you. So the blue LC
There we
fiber
go.
port on
LC
the end
fiber right
is
there.
where that LC connector plugs directly in.
Yes. And this particular piece, this is the high-end piece. It has Ethernet as well, so you can also extend Ethernet. Also, something of note, unlike traditional HDMI extenders, which have power over Ethernet or power over copper, this is a piece of glass, so no power is extended. So always plan on having power on both sides when you use fiber extenders. Just a quick tip I wanted to hit before we go to the next piece. So some of the other devices that we sell that have fiber interconnectivity would be like stacking switches. So if you've got a project that has kind of like multiple wings in a residential, or like if it's a commercial, if it's got multiple buildings, you can interconnect those two, and you can have the network all built together in the ecosystem by stacking your switches. And in this case, we sell Unify, Luxel, Arachnus. Basically all of our switch vendors now have stackable switches that stack off SFP. And for very short distances, like stacking switches within the same rack, you can use the copper stacking cable. But for the most part, you're going to be stacking using fiber. And same thing with Luxel. Luxel's got switches that do the same thing, or Arachnus. Arachnus has switches that do the same thing. And where this is very important today in our system designs is with applications like media over IP. So, Snap AV and all of our companies, the Snap AV Pro stores, Valuetone, AllNet, MRI, and Custom Plus, we've got the binary MOIP, which is media over IP, so HDMI plus audio plus video over Ethernet. And the best way to extend that is using stacking switches with fiber. And then also in select locations, we've got Just Add Power and other vendors at Lona and other vendors that do the exact same thing with slightly different wrinkles, slightly different feature sets. But the most important takeaway that I wanted to share today is that fiber is our backbone for getting that very, very high bandwidth signal around these projects with super low latency.
Well, it's in particular when you're talking about media over IP, obviously you're dealing with, millions or billions of data packets all needing to get to the right place at the right time. And if you're dealing with copper infrastructure, there is going to be some latency. With fiber infrastructure, especially over the longer distances, or if you've got a more complex system, the fiber just virtually eliminates that latency. So those data packets stand a much better chance of getting to the right place at the right time without being dropped or being, being out of sync with one another.
Yeah, fantastic point. And then other devices that we sell, like one of our other partners is TechLogix Networks, and one of their components that's pretty handy is a media converter. And what that basically does is it allows for a point-to-point connection. So let's say you got an access point or an IP camera or an Ethernet connected device that's way out, like in an outbuilding or gatehouse or something like that, and you just can't get fiber out there because fiber, remember, our limitation on fiber with Ethernet is 100 meters, and that's 90 meters of installed, and then the spec is 5 meters of patch on either side. So 100 meters is our total point to end, including all of our terminations. So sometimes 100 meters is not enough. So as you can see here on this spec, that you can take this thing, you can take these things out hundreds and hundreds and hundreds of meters. Gary was sharing with us that the single mode product can go out. What's the longest functional distance for single mode, Gary?
In theory, it's infinite. It can literally, I mean, we can go out. They generally go out. You can buy the SFP that goes into that port there where it says TXRX. You can buy a single mode SFP that can take you out 40 kilometers or about 25 miles.
Yikes. Yeah, and that's why these devices use SFP as opposed to like the AV Pro Edge piece. The AV Pro Edge piece, they know that we're probably not distributing HDMI multiple kilometers, but this device we might. So they leave it open-ended. You just you choose the appropriate SFP for the type of fiber that you're going to use to extend to suit the application. So Gary, I think I'm done for the side that I wanted to present. So
Okay.
let me flip this back over to your screen if you're ready for that, and then we're going to do some Q&A.
Yeah, well, I really only have just the, I'll leave my credentials up there so you can see how to contact me.
Okay, that's probably for the best because I need to get it off my screen so I can start looking at the dashboard.
Yeah.
All right, hold on.
Oops.
Okay, should be you.
All right. I just got to get
It just say click to exit. Okay. Did you get something put up there?
there we go. There we go. Is it back? Are you there?
Yeah, I'm here.
Do you see the?
No, I don't see your screen.
It's weird. Okay. Doesn't matter. As long as we've got audio at this point, I think that's all that's important.
That's fine. Okay.
Oh, there we go. I think that's what I needed to.
Oh yeah, I do see your screen. It's black. There we go. There's
okay.
your. Okay.
Yeah. So if we can open up the floor to any questions,
Sure.
like I said, audio is probably the best way to do this. We don't really need any video. So.
No, I'll just ask the questions. So one of the questions that came up is older installations where there's dark fiber sitting in on a project.
Mm-hmm.
So this was something you and I talked about on our call before we started the event. So the TIA, the CEA, CEDIA, and other industry organizations have standardized structured cabling going all the way back for like 20 years now. And 2+2+2 was the standard for structured cabling, and it was installed in a lot of homes prior to the burst of the housing bubble.
Mm-hmm.
So there were 2 RG6 quads, 2 Cat 5Es, and 2 fibers, but they weren't what we would consider current fiber. If you want to pull back to one of those, I was going to talk about the OM because I think it was OM1 or OM2, wasn't it, Gary, back then? It certainly was glass.
So if it's OM2, we're in good shape. All right. So okay. OM2 still facilitates that standard 50 micron core with 125 micron cladding. All right. So that we're good to go with that. Where it becomes a bit more difficult is if it's really old. That 50 micron core was actually a 62.5 micron core, right? So imagine trying to plumb together a 4-inch pipe with a 3-inch pipe and trying to make it not leak without the appropriate coupler to it. That's kind of the challenge that we're dealing with. We're trying to get something that's 62.5 microns to connect to something that's 50 microns. So that becomes a bit more complicated and would need some help. We can do it, just needs a couple of adapters. Yeah, if you run across that where you've got OM1, which is going to be your lower grade, there we go, your lower grade older technology, that's going to be a 62.5 micron core in there as opposed to the 50 micron which you're going to see today. And that's the only thing we need to deal with. If you've got OM2, 3, 4, or 5 already in there, then it's going to probably be that 50 micron core and we're good to go. You can use any of our connectors straight off the bat.
Nice. Is there usually a visual identifier on the jacket, or would the best way to just be the Google?
These numbers that I'm showing you here, the 9125 or the 5125, that's going to be printed on the jacket. All right, and so that's going to tell me what grade of fiber that is, whether it's single or multi, and what grade of multimode it would be.
Perfect. Okay, and it seems like my recollection is that the vendors for the structured cabling kind of migrated into fashion. So Belden was the key vendor for a while, then it was CommScope, then it was Coleman, then it was there were several players of this bundled pre-bundled cable, and each one of them had their own, their own builds. So the best thing if someone's trying to take that fiber and make it live is to try to find the information on the jacket and Google the part number if the specifications aren't
Yeah.
part
I mean,
of the
the
jacket.
part number on the jacket's going to tell me a lot.
Okay.
But yeah, if you can get me the part number that's printed on the jacket, or just give me a screenshot or a picture of the print legend on the jacket, we can tell a lot from that, and we can kind of take it from there.
Perfect. Okay. All right. So our next question is, when is it okay to use pre-terminated fiber? So at this point, that's a similar conversation to pulling pre-terminated HDMI, where you just have to be careful using a hood or a sleeve to keep that connector from getting damaged in the pull.
Yeah, it is. I
In
mean,
your experience, what are the pros and cons of doing it yourself versus pulling pre-term?
well, the pros and the cons are, obviously, if you're terminating yourself, you've got to invest into the kit, which, by the way, is a dealer cost of $500. So if you're going to be doing a few of these, $500 isn't a big investment. That's one of the things we've taken pride in doing, is reducing the price of the termination kit down to a very manageable fee. So you got the initial investment of the termination kit, obviously, if you're terminating your own. But then you've got the ability to make your patch cables exactly the length you need them to be, versus having to buy pre-terminated patch cables, which potentially you end up with too much or too little. The downside to buying pre-terminated, of course, is you've got to get that connector through the infrastructure of the building. You've got to be able to pull that fiber from point A to point B without damaging it. Now, they do make things which protect those heads, that protect those connectors, that pulling socks and things like that. But I mean, honestly, they're very, very fragile. I mean, if you're not careful, pulling a patch cable through any kind of stud work or conduits or things like that, it can easily damage the connector. If it's a very quick, simple rack to rack type pull within a utility closet or something, then yeah, patch cables are probably the way to go, because you can pull those relatively safely and easily. But if you're pulling through a building, I would recommend pulling bulk cable and terminating yourself, just because you're not going to compromise the connectors.
Okay, so the next question that pops up is about pulling the cables. So Mark is asking questions for, if you want to go back, you had a slide on the types of cable construction.
Mm-hmm.
So what is the most common style of cable that's pulled for a loose cable without being in a conduit, through stick frame or in like commercial installs where it's going through the punches in the steel studs? Are a lot of people where the conduit's not required still using conduit just because it makes it easier, or
No,
is this
not
something
really.
that's
So, I
pulled
mean,
right alongside of category and coax
is this
loose within the
commercial or
stick frame?
residential?
Mostly residential, I'm sure.
So the slide I have up now, the duplex here. Can you see my mouse moving, by the way?
I can for sure.
Okay. So the duplex here, the 2-strand OM3 multimode, is by far and away the best-selling product we have. All right. That's 2 strands of multimode fiber, and you would pull that from from the rack to a display or an access point or a projector location. That's used between SFPs on the back of switches. This by far and away is the most commonly installed product. A lot of folks are actually pulling 2 of these together to give it 4 strands, or if they're not doing that, they're pulling a micro distribution like this one here, which has got the 4 strands built into the one jacket. So the only stipulation on that is, okay, do you need riser rated for resi, or do you need plenum rated jacket for commercial? And we offer both. So realistically, the most commonly used product we sell is the duplex, the OM3 duplex, in either riser rated or plenum rated.
Okay, perfect. All right. And then, so Anthony's asking about the SKU mix at AllNet. So that might be, are you privy to what our orders are consisting of recently?
I can, but I would prefer to do that not online live, because it brings up.
That's fine. So Anthony, we're definitely carrying the duplex that Gary was just outlining. The devices like breakout some of the armored product for outdoor use, for, let's say, for an outbuilding or something like that. Those are special order. And then also, I believe we're doing builds with you as well, right, Gary?
Yes, yeah, I believe
Okay.
that to be so.
Yeah. So I don't know what market you're in, Anthony, but I'm with AllNet. So if you want, reach out to me after the thing, and I'll loop in your salesperson or your contact, and we'll share with you what we've got and then what we also have available, and see what you need. If you've got a project that's in play, we can work on getting that spec'd out for you. All right, so Anthony follows up here. How many individual lines are protected in a micro distribution bulk? That's a great question because it's not really clear.
We can basically, what happens is we build them out in factors of 12. So within each 3 millimeter tube, we can get up to 12 fibers. So in actual fact, we can build up to 144 strands in one outer jacket. It becomes about an inch or so in diameter at that point. But within each 3 millimeter jacket, we can get 12 fibers.
Okay, and what about the breakout? And what's the difference between, what's the application difference for speccing a micro distribution cable with raw fibers inside of it versus using breakout with the extra cladding or the extra
jacket?
Yes, exactly.
Yeah, purely, honestly, the application would be identical. It's just a matter of whether you've got the room to pull a breakout cable, because the breakout cable is bigger. The breakout cable only really has 4 strands in it. It doesn't go up to the high strand count that we do with micro distribution, but it's got 4 strands of fiber in it. Each one has its own jacket around it. And so that is a bigger cable. That's probably comparable to like a 16/4 speaker cable in size. Okay, so it's a bit bigger than the 3 millimeter jacket that the micro distribution comes in. Application's the exact same. It really boils down to how much stress or how much exposure the product has to outdoor elements, or not outdoor, but external elements. The potential for it to be damaged. Obviously, the breakout cable has more protection around it than the micro distribution does. Although realizing, when you do start to use our fiber, you'll realize that the fiber itself, within all the jacketing and within all the cladding, is actually very, very strong. But if you want that little bit of extra protection just because it's going to be exposed somewhere, or you'd prefer to have those extra jackets, then the breakout's the way to go. But if you've got a very high strand count and you've got a very small amount of real estate to get the fiber down, the micro distribution is the way to go every day.
Okay, and then, sorry to put you on the spot with this one, but Anthony has another follow-up question, and I forgot I was going to ask this question as well. Fan out kits. Fan out is definitely our number one, how does it work and why question that we get when it comes to fiber.
Okay.
Can you pull up an example of a fan out and talk about the differences in application?
Okay.
And
So
also show a visual.
Yeah, let's stay on this slide for a second. With the micro distribution cable, we've obviously got one jacket where we've got up to 12 micro fibers in there. You've got 12 fibers, each one of which has that soft peel acrylate that you peel off between your finger and thumb, correct? So with a fan out kit, all you're buying, and I'll see if I can find one to look at, with a fan out kit, all you're doing is you're buying a kit which consists of 12 empty tubes, all right? And you actually strip back 24 or 36 inches of that outside 3 millimeter jacket. So you would get rid of that 3 millimeter jacket, strip it back to those individual fibers, and then you would feed it into these 12 empty tubes. And what they're doing is they're just building it up to, in this case, it builds it up to a 900 micron size, okay? But if you go with a full breakout kit, it's building each of them up to a 3 millimeter tube, each of which has that Kevlar around it. So if you remember the Kevlar, the yellow aramid yarns here, each of those tubes on a breakout kit comes with those aramid yarns. So you can build the fiber up to that 3 millimeters and have those aramid yarns within each one. And again, our fiber is actually strong enough that fan out kits and spider breakout kits, they're not really necessary because our fiber is already very, very strong and resilient. But it just freaks people out when they see those tiny little fibers in the back of a rack exposed, it freaks people out. They don't like seeing it. They think it's vulnerable. So that's why people use these fan out kits to build up those individual fibers to either the, the 1 millimeter or the 900 micron or the 3 millimeter size, just to make it look like it's a bit more, heavy duty and robust. Does that make sense?
Absolutely.
So yeah, what you're doing when you're buying these kits is you're buying 12 empty tubes, and you just feed the individual fibers down them, and then you terminate. You cut them to length, and you terminate to whatever size you need to.
All right. The other question that pops up quite a bit, and I know this was in one of the slides, the termination points, like a rack-mounted termination, almost like we would do with the patch panel on with copper. The question that popped up was, when is the right time to use? There we go, rack enclosures, I believe. When is the right time versus point to point?
Generally speaking, our industry is going to be using more point to point, especially residentially. When you're dealing with commercial, that's when you're going to be dealing with these higher strand count type infrastructures where you're using the adapter plates. To answer your question simply, if you can go point to point, it's always favorable. All right. The reason being that every time you have an adapter or a plate or a point of termination, like with any cabling infrastructure, that's a point of weakness. It's a point of loss. Okay. And although we can get those losses down to almost zero, it's still a potential point of failure. So whenever you can try and do point to point, that's always best. If you've got a high density application where you've got several switches or you've got several things going to several different locations, obviously it becomes necessary to have a rack type enclosure. But again, if you get to a point where you're dealing with cable infrastructure that requires multiple strands like this, let's work with you to see what the application is, and we can sort of recommend best practices for that.
Okay, perfect. And so, and when the question gets popped up here at our offices, what we say sometimes is, it depends on the level of the project. There are certain projects where the customer their expectation is the electronics that are going in today are going to come and go over the next couple decades, but they want the infrastructure to last. They want like something that they can work with for 20, 30, 40 years. I mean, we've had, kind of the dealers come in, and when I was in the field, we would inherit projects that were 30 years old. Yeah. And we're thankful when there was forethought put into it, and we were able to reuse some of the infrastructure that was in there 30 years ago. And like I was saying a moment ago, with the 2+2, these structured wiring products being out there and being pulled in some of these homes, it's kind of neat when you can find a run and you go into that project thinking it's going to be $5,000 or $6,000 to retrofit a couple pieces of cable through the house, and then you realize it's already there. All we have to do is buy an adapter and test it and certify it, and then it's good. We can save that customer some money and maybe put that budget into something that's going to serve them better tomorrow.
Yeah. I mean, to that point, I mean, if you think about it, every time we've had a changing technology using copper infrastructure, we've had to go from some kind of twisted pair, whether it was the original bell wire to Cat 3 to then Cat 5 to 5E to 6 to 6A. Now we're talking about 7 and 8, right? So whenever technology moved on, we would have to pull new infrastructure because the technology within the cable would change as well, where the cable would be up to spec to keep up with the hardware. Fundamentally, fiber optic, with the difference being the 62.5 versus the 50 with the multimode. Fundamentally, fiber optic's been the exact same for 60 years. All we've done is we've made it stronger and easier to use. So I don't think the fundamental construction of fiber is going to change anytime soon, given that it's it's kind of tried and tested for 60 years. I mean, and it's also what they run under the oceans. I mean, it's going to be a massively expensive exercise to run different infrastructure around the world. Google and Amazon and Apple are the three primary owners of the fiber under the oceans, and I don't think they're going to go to too much extent to replace what's there, because it works and it's worked forever. So I think fundamentally that the technology we're dealing with now and has been tried and tested for decades is going to be around for a while.
Perfect. Yeah. Okay. Anthony asked another question here. How do you terminate without the outer shell, such as the multi-strand with the 12 fibers within one jacket?
So
So I
with
think it sounds like part of what he's asking is if there isn't a bundle of yarn with each fiber.
There's
How does
not.
that?
So in actual fact, I'll see if I can find it
Okay.
and send it to him. If you can get me the information for Anthony, I can get something to him, or I can send it out to the group. There within each
If you'd
packet.
like, you can share it with me, and I'll do a follow-up email to everyone who registered and everyone who
Sure.
attended.
Within each packet of connectors, there are various what they call flocation tubes. They're little sort of half-inch long tubes. You remember in the video they slid that little yellow tube over the fiber before they clamped down on it.
Yes.
Well, that was to build up a 2mm jacket to the 3mm opening of the connector. There's also other tubes in there which build up the small fibers, the individual fibers of the micro distribution. It builds them up to that same 3mm size. And again, our fiber is strong enough that you actually don't need the aramid yarns to be trapped into the back end of the connector. If you're protected by a rack enclosure where your product is secure and nobody can get to it, there's no reason why those small fibers are not able to be exposed. But again, it freaks people out, and so that's why you use fan out kits and build out kits. But yeah, in the back of the connectors, there's tiny little tubes that you feed the individual fibers into, and that's what you clamp down onto with the back of the connector.
Perfect. Okay, thank you.
And we've got
All right.
videos online, guys. One of the things I'll do with you, Rick, is I'll send you hyperlinks to the videos. We've got various videos giving examples of how to do these types of things online. So you can take 10 minutes and just take a look at the videos, and it becomes very clear to you.
Perfect. Okay, the last question that pops up is in regard to further training / certification. Does Cleerline offer a certification platform or an in-person training?
We do. It's actually something we've just launched. We're offering it in various cities around the country at various times through the course of the year. We've just started it. Our first one is next week in Vegas. We're doing others in Detroit and Grand Rapids and various other places. I'm going to release a schedule of those certification classes. It basically consists of most of what you've seen today, but then we go through more detail on actual, termination, testing, and then there's a test at the end of it. We give you a termination kit. So the course comes with a fee of $500, which is the same cost as the termination kit, but you take a termination kit away with you along with your certification. All right. So you'll see more on that as it comes out. I'm releasing. I head that up. So you'll see me release that schedule in the coming days or weeks, and you'll be able to register online and come to a 3-hour session. There'll be a test. We'll work together. We'll make sure you pass, and you'll go away with a certification and a kit for $500.
That sounds perfect. So as you're putting these together, I would remind you that we just built a brand new giant training room in our Troy, Michigan branch in Detroit. I'm sitting in it right now. So
Right.
you're certainly welcome to use our room.
Okay. Well, that's always appreciated. Thank you.
Yeah, we've got rooms all over the country as well. So I mean, let's touch base on that, and we'll share that with Bill, and we'll see which dates and which venues make sense. And because here's the thing, the dealers like coming to our building. We like having them in the building because then they can walk around and see what else we sell and take some stuff with them. So it's a win for us. It's a win for you instead of renting a ballroom somewhere.
Yeah, no, absolutely. Yeah, for sure. I mean, we can do it either way. We can either use your premises or we can do it, agnostically in a hotel somewhere. So, people who aren't necessarily in your channel, they might be in, I don't know, a data center channel, something like that. But
Okay.
Something that's not normally your customer might want to attend the same class. So we can be in a place that's neutral.
Okay, that's fine. We'll touch base on that and see if we can work that out. All right, I think we've gone over by a little bit. So everyone on the West Coast, thanks for staying with us into your lunch hour. And I don't have anything further. So Gary, I wanted to say thank you for the taking the time today to do the webinar presentation. This is a great one. So we had a good engagement and we had a lot of thumbs up in the chat box. So
Good.
thank
Okay,
you for your time today.
well, real quick, just in case
Sure.
you need it. Once again, if you need me for anything, please feel free to email me. That's my cell number again on the screen now. You know, I'm in Pennsylvania, so on Eastern Standard Time most of the time when I'm not traveling. So feel free to reach out and I'll help anybody I can whenever I can.
Gary, you're the best. All right.
Thanks,
Thanks
guys.
everyone for joining us today. And Gary, thanks again. Let's talk soon.
Yep, very good. Thank you.
All right. Thanks everyone.
Bye-bye.